Welcome everybody to Unit Testing Web and Mobile Applications. As Luke mentioned, my name is Arthur Kay, and I am a Solutions Engineer on Sencha's Professional Services team. Joining me today is Mats Brintz. Mats, do you want to take a second and give yourself an introduction?
Sure, thanks. My name is Mats. I've been in the Sencha community since about 2007. We make some components for XJS and Sencha Touch, and also Siesta, a unit testing framework for Sencha's components.
Fantastic. Thanks, Mats. So today's webinar is really a follow-up to two articles that I've recently written on Sencha's blog that deal with the topic of unit testing. And for those of you who may not have had a chance to read those articles, I'm going to start from the beginning and kind of dive into some detailed examples using a sample project that I mentioned in those two articles. Specifically, we're going to cover some challenges that web developers frequently face when trying to integrate unit tests into their projects. And there are three main topic areas that we're going to cover today. The first being having valid JavaScript syntax, moving on to building logical unit tests for your code base, and then finally digging into creating some integration tests for your user interface. There are going to be a variety of links and resources that both Mats and I mentioned throughout this presentation, but don't rush to write down those links. We are going to make these slides available on a variety of channels at some point after this presentation, and as Luke mentioned, the presentation itself is being recorded and you'll have that available to you later today or tomorrow. Finally, at the very end, we are going to have some time for Q&A, so please post any questions you have to the chat window. So in my role on the professional services team, I'm frequently asked about unit tests. It's a topic that a lot of people want to know about, and it seems like everybody wants to integrate it into their projects. But the fact is that few web developers really seem to understand the fundamentals of unit testing. Unit testing web applications is a hard problem to solve, and in my experience, I'm not sure that there's a quote-unquote best way to actually do it. But there are a number of good practices that I think everybody should be following. And those practices are the things we're going to talk about today. So starting from the beginning, let's ask ourselves a question. What are unit tests? Unit tests are a tool for maintaining code quality. So they are a way to gain confidence in your code. Unit tests are a verification that bugs exist. And this is a point that I want to sort of emphasize, that unit tests don't tell you that your code is free from bugs. If your tests pass, that doesn't mean your code doesn't have bugs. And in a similar manner, just because you have passing tests doesn't mean that you have working code in your application. And these are some ideas that we're going to go into in more detail. Unit tests don't solve everything. They're not going to replace actual QA testing of your application. So that's just something you really need to keep in mind as we move forward in this presentation. Let's talk about some challenges that web developers often face when writing unit tests. One of the first questions I always get when talking to clients about unit tests is, what do I test? And in order to answer this, let's take a step back and look at the architecture of a typical enterprise application. So enterprise apps are usually composed of many tiers, and these tiers help to separate the responsibilities of our code. Now, I want to point out that the presentation layer of an application is very different from the underlying tiers. And this is partly because of the languages that are used to create the presentation layer. But it's also because the presentation layer has a very different purpose and is used very differently than the underlying tiers of the application. For example, your server-side layers are usually written in strongly typed compiled languages, and these might be things like Java or C#, whereas the presentation layer of your application is written in HTML, CSS, and JavaScript, which are runtime languages. Your server-side layers will typically only run in one environment, and that will be the server on which they're deployed. But your presentation layer has to run on many devices, and these may be either desktop or mobile. It may be a Windows machine or a Mac or a Linux machine. So there's a tremendous amount of variability in the environment. And although larger companies do have QA teams dedicated to testing applications during a cycle for release, but that doesn't solve the development problem of writing unit tests. Now, web applications are inherently difficult to test. Developers have to consciously write testable units, and if you aren't conscious about keeping your code into small segmented units, you end up with what we often refer to as spaghetti code. Sencha's MVC architecture in both XJS and Sencha Touch will help you as the developer to separate your logic and your presentation code. And in the examples today, I'm going to try to clarify what developers should be testing and try to demonstrate some good practices for writing testable code. So another challenge that developers often face is that of trying to automate their tests. Far too many developers simply test their code by clicking through the application. And because JavaScript is not a compiled language, a variety of runtime errors can be very hard to prevent. And this is really the value of having things like unit tests, is preventing these errors from occurring during runtime. Furthermore, when you have unit tests, whether they be checking for syntax, checking your logic, or checking the interface, you need to make sure that they're run on a regular basis. And this can be through a variety of mechanisms, whether it be through a continuous integration server, through some of your version control hooks, or some other tools that may be available to you. So we're going to try to answer questions today about how to best automate your unit tests. So the last challenge that developers usually face is that of selecting the right tool. The fact is that there's no single tool that can solve all of your testing needs. Furthermore, not all of the tools that are available will integrate the same way with your systems or your development process. And there are tons of tools to choose from. Finally, not all companies will allow their developers the freedom to install some of these tools without going through lengthy approval processes. So choosing the right tool is very often a challenge for developers. And this webinar is trying to offer one possible solution for testing your Sencha applications. Keep in mind that the specific examples that we're going to show you may or may not fit into your development process or to your systems, but the webinar will give you a tremendous amount of understanding about how to solve these problems. So very quickly, I want to mention the sample application that we're going to use throughout this presentation. Sample application is an XJS4 app that connects with the meetup.com API. And close that window. So this sample application is available on GitHub from Sencha Pro Services Unit Test Demo. And all of the code is freely available to you. Scrolling down into the README, you should see the 2 links to the Sencha blog articles that I'm going to be discussing today, as well as some other notes for getting the application up and running. the application itself, as I mentioned, is an XJS4 application. It is a very simple application. It involves 2 grids inside of a tab panel. And these grids are going to display the upcoming and past events from the Chicago Sencha meetup group. And inside of these grids, you see 4 columns, namely the name of the event, the date on which that event happened or will happen, the number of people who RSVP'd for the event, and an actual link to the external meetup page. If you were to double click on any of these rows, you get a window that pops open containing the names and the profile pictures of the people on meetup.com who came to this event. So now that we know what the sample application does, let's talk about some realistic strategies for testing this application. Back in August 2012, my original article ran on the Sencha blog. And inside of that article, I stressed the importance of having correct JavaScript syntax. So having correct JavaScript syntax is tremendously important because JavaScript is not a compiled language. And that means that syntactical errors can be encountered randomly at runtime. Compiled languages like Java or C# don't have to worry about this. So if you're writing an application in C# and you've got a misplaced semicolon or an unterminated string or some other sort of syntactical error, the application physically won't build. And so you know there's something wrong and you get immediate output from your compiler. Well, that doesn't happen in JavaScript when it runs in the browser. And this can be particularly troubling in older versions of Internet Explorer. There are many tools that you can use to validate your JavaScript syntax, and perhaps the most popular of these is JSLint. Now, not everyone likes JSLint because not everyone agrees with Douglas Crockford, but that doesn't mean you shouldn't be validating your code. It's still something very important you should be doing. But the problem is that this is a hard process to automate. You could copy and paste your code directly into the JSLint website, but that's entirely too much work for an application that has thousands of lines of code and many, many classes. Some IDEs even have plugins that alert you to bad JavaScript syntax. But these tools don't prevent you from checking in bad code to version control. So there's a better option. And in my original post, I discuss a tool named PhantomLint. And this is a pet project of mine that lives on GitHub. And we'll get to this in just a second. But I wanted to point out that in the months since that original article was published, PhantomLint has evolved a little bit into a more robust tool, which I've rebranded as LintRoller. As I mentioned, it's available on GitHub, so you can fork it and play with it, or you can install it directly in your machines via NPM because it runs on Node.js. LintRoller currently supports JSLint, JSHint, and Esprima. And I'd like to show you an example of how a tool like this works to validate your JavaScript syntax. So in the sample project, I have a folder named syntax. When you open this folder, you can see several files. And we're going to focus on this file named lintrunner.js. This is the config file, which tells LintRoller which validators to use. In my case, I'm going to use all 3, JSLint, JSHint, and Esprima. It tells LintRoller which file paths we should validate. In our case, it's going to be the entire application. But we're going to exclude some directories because maybe we have third-party dependencies, documentation, resources of some other kind. so we don't want lintroller to bother validating those files. And because lintroller runs on Node.js, what we can do is go to our terminal, navigate to the syntax folder, and simply run node lintrunner. And as we can see, lintroller will find 22 JavaScript files in this project. It finds a variety of errors and logs them to an error file. The error file can be found in the same directory under errorlog.txt. When we open this, we can see that lintroller will tell us the name of the file, the line number, the character number, and the reason why our code did not pass inspection. But the really cool part is that lintroller provides an error code on failure so that you can use this tool with things like pre-commit hooks. If you're using Git or SVN for your version control system, these systems are essentially built to do things like this with pre-commit hooks so that you can validate your code prior to committing your code. You could also use this tool with things like build scripts on a continuous integration server or a variety of other mechanisms. So there are some challenges with using a tool like lintroller. First and foremost, not all companies will allow you to use Node.js. So you may have to get approval from your IT department to install Node.js or to install a variety of Node modules. Secondly, not everyone uses Git or SVN. So if you're using a version control system like Perforce, you may not have things like pre-commit hooks to use. So the challenge here becomes finding some other way to automate the process of validating your code. While checking our JavaScript syntax is certainly important, it's also a very high-level look at our code. It doesn't really tell us about the state of our business rules or the functionality of the application. So again, in my original post published in August of 2012, I discuss the idea of logical unit tests and that they objectively verify your data. And you can think of this sort of as the mathematical proofs you may have studied in high school. Logical unit tests give you a great deal of confidence in your business code. But the question becomes, what should you actually be testing in your application? So logical unit tests necessarily imply that you're not testing the interface of the application itself. Some of the things you might consider writing unit tests for are things like your model validations, because your models get used throughout the application. Some other items might be a variety of utility classes that perform complicated data transformations. These are the things that make perfect sense to write logical unit tests for. And in the sample application, I chose to use a unit test framework named Jasmine. Jasmine's a popular testing framework. Sencha uses it internally for testing both the XJS and the Sencha Touch libraries. And it boasts a very readable API. And we're going to see this in just a minute. When you use Jasmine out of the box, it's designed to run in your browser, but that's a terribly manual process. And as we mentioned before, the challenge that web developers face is trying to automate this process. So you could use some of the available plugins for your development environments. And JS Test Driver is a fantastic plugin for running your Jasmine tests. But again, it doesn't prevent you from checking bugs into your code. So in the sample application, I'm choosing to use Phantom.js as part of a pre-commit script to prevent failing tests from being committed to our code. So let's take a look at the sample application again. So before we look at the actual unit test for the application, we are going to look at one of the views that we're going to be testing. And in the sample app, what we're going to be looking at is the actual grid that's displayed twice in the application, once on the past events and once on the upcoming events tab. So this is the events view. It simply extends the ext grid panel class, and it doesn't really do a whole lot that would be considered special. I'm choosing to use an init component method, mainly because I want to swap the URL that is being used for the data store. But the point that I want to focus on is the column renderer I'm using on the fourth column of this grid, which is the URL column. To avoid having spaghetti code, I chose to not put an anonymous method directly inside of this column model, because that would have been very difficult to test. Instead, I created a link renderer method, which is a class method on the class itself. So in this way, I can create an isolated unit to test via Jasmine. And as we can see, the link renderer method is fairly simple. It simply takes a value and wraps that value in an HTML blob. So this makes an easy test case to write. If we navigate to the unit tests folder of the application, we can see that I have a variety of files in here, one of which is a spec-runner HTML file to physically view in the browser. But since we want to automate this process, I'm including both a shell script and a handful of supporting JavaScript classes to work with Phantom.js. There's a folder that mimics the app architecture of the application itself, and I use this to help organize my Jasmine tests. If we look inside the Jasmine test itself, we can see the readable API that I mentioned a moment ago. We can see that we're going to describe the behavior of a Chicago Meetup View events class. We're going to skip down to the bottom where I want to discuss the internal methods of this class, specifically the link renderer method. We can declare that this method should return a string, specifically one that's formatted as an HTML link snippet. So inside of this test spec, we can create some expectations about this method, namely that the type of this property is in fact a function, that what this function returns is in fact a string. So those may be fairly trivial expectations. Perhaps you want to do a more robust check to see that what's being returned is in fact a valid HTML blob. And we can do that using a regular expression. First, we create a reference to the return value of this method, and then we test that reference against a regular expression. And we can assume that this test is going to pass. Going back to our command line, we can navigate to the unit test folder, and we can run the shell script that I include. This shell script will launch Phantom.js, and Phantom.js will then run our Jasmine tests for us. Here we can see that I have 11 test specs defined and that none have failed. This shell script, in a very similar way to what we did with the lint roller tool, will provide you error codes so that you can hook them into your pre-commit hooks or build script and prevent bad code from being either deployed to a server or from being committed to source control. So there are some challenges that developers will face when writing logical unit tests. First and foremost, you have to decide what you want to test. And as I mentioned earlier, some of the low-hanging fruit would be your model validations or your utility functions. Going a step further, you still have to have testable code. So if you have very long methods in which lots and lots of data calculations happen, that's not an easy unit to test. You want to try to have smaller functions. You also want to make sure that you're not testing the user interface itself. In the example I showed you, we were testing the link renderer method, which gets displayed on the screen, but we weren't testing the display itself. We were testing the actual string value that was returned. Some other considerations are that in some cases you may have to mock data or mock the APIs that are being called in your tests, because you can't always rely on live data. Live data may slow down your tests, and if you have a variety of HTTP requests that can't get fired in the test environment, then your tests may end up failing. Last but not least, we have to be careful to avoid having bugs in the tests themselves. So our tests are written with JavaScript, meaning that there can be some tactical errors, and there can be logical errors in your tests. So trying to avoid those bugs can be a challenge in itself. Now, the last piece of the unit testing puzzle centers around the concept of integration tests, which are sometimes referred to as functional tests or UI tests. This topic was covered in my most recent article on the Sencha blog, published just a few weeks ago. These UI tests will subjectively validate the appearance or behavior of your application. It simulates real-world use of either isolated widgets or the application itself. And in this sample project, I chose to use Siesta to perform the integration tests. If we jump to the sample project, you will find these tests in the UI tests folder. And I've broken these tests into two categories: a UX for the isolated widgets that we want to test, as well as an app folder, which is more of an end-to-end QA testing cycle. Rather than diving into the examples in the sample project, which I would encourage you to do on your own time, I'm going to pass the ball to Matt to discuss more of what Siesta is and what it does.
All right.
Yeah, let me pass this over to you, Matt.
All right. So now hopefully you should see my screen. And yes, so basically the background of Siesta came out of a need we had when we upgraded our scheduling components from EXTJS 3 to 4. So we kind of realized we had a really big need for something like this, but we couldn't find one available. So we ended up writing Siesta ourselves. And Siesta runs in the browser, or you can launch it from inside of your IDE. And you can do that thanks to some automation scripts that we have written that can talk to Phantom.js or Selenium. Of course, the biggest thing about Siesta is that it offers very easy integration with the Sencha frameworks like EXTJS or Sencha Touch. And since it offers you integration test capabilities, you can do things like clicking, typing, dragging, tapping, and all sorts of stuff with any element on the screen. And if you want to know more, you can go to our website. It's www.brimton.com and click on the Siesta link. So a bit of an overview of Siesta. Siesta is actually fully written in JavaScript, and it offers testing for any JavaScript, jQuery, Node.js, and of course EXT and Sencha Touch. You can use it to write plain, simple unit tests or more complex end-to-end UI tests. You'll see later that the UI is based on XJS, so it should look fairly familiar to you, I think. Each of the tests you launch is sandboxed, and the ultimate proof of that is that we actually use Siesta to test Siesta itself. So you have a new iframe every time you launch a test, and you don't have to worry about cleaning up or setting up in front of running each test. Siesta can also help you find global variables after each test. I'll demo this in a bit. And I've already mentioned the Phantom.js scripts and Selenium scripts are also in the package. And a great deal of Sencha awareness. We know quite a bit of how the XJS and Sencha Touch frameworks are built, so we offer some nice abstraction sugar to help you write very readable tests. So there are typically two aspects of UI testing, the way we see it. So you can split it into kind of isolated UI unit tests, which is what we prefer at Brinton. And you can also look at that from the viewpoint of a black box test, which is also sometimes called QA testing or Selenium type testing. And the nice thing about the UI unit approach is that you write it in the same way you would with any type of test. You do it in a unit test approach. You take one component API and test that at a time. Once that's tested, it's safe to refactor the component internals, and you can do this test-driven development style, so you can start by writing a test, which is a very nice way of coding. And the upside of the black box approach is, of course, that you get an answer to the question, does my application really work? It's like an end-to-end test of your entire app. It's a bit more complex to write such tests. You have to take into account that a lot of things are asynchronous. You have to wait for stores to load, animations to complete, and various conditions. And once such a test fails, you might not necessarily get a good context as you would in a unit test type test. So Siesta, of course, speaks Sencha. It knows about Sencha components, it knows about stores, elements, and higher level stuff like component queries and so on. So this means that inside of your test, you can say stuff like wait for rows visible and pass in a grid. You can wait for a bunch of stores to load and pass in an arbitrary number of stores, and you'll get a callback once it's done. You can target things on the screen through various target locators, such as X types and so on. So you can say click and pass a button component query, or you can type into a text field. If you have observable classes, you might want to verify that a certain observable fires exactly the number of events you expect it to throughout the lifetime of a test. Very useful stuff, actually. And one thing that's really nice that we mentioned on our blog lately is that we can launch the test from within our IDE. So what you typically do is you pick some very nice key combination that you can launch with a single hand. You map it to our Phantom.js launcher, and then you can just run a single test in isolation very, very rapidly. And this is a very nice thing to have when you're debugging a test or you're writing a new test. You don't want to have to swap to the browser window. Some things you should consider when writing UI tests, though. So UI tests are by nature slower and also more fragile because they involve the DOM, and the DOM can be a tricky beast. And since differences between browsers are typically seen in the DOM rather than in the JavaScript space, so you definitely need to run your UI tests on many browsers. Doing it in Chrome and Firefox is not enough. You definitely have to do IE, a few versions of IE as well. And since your time doesn't really scale, you absolutely need automation too. So you have to have some type of CI process that runs these tests either nightly or maybe on every commit and so on. And also, simulation is not the only option, you can also consider other options when writing your UI tests. So I'm going to tell you a little bit about a challenge we had recently, which was to test our Sencha Touch scheduler component and the pinching feature. So simulating multi-touch inside of your browser is not really a simple thing to do. So we kind of struggled with this feature, and we saw bugs coming back that we had already fixed. And the underlying reason was that this feature was not being tested by our nightly build process. So we kind of thought to ourselves, how can we do this better? And we looked at the actual feature class that handles this. And it looks sort of what you see on the right. We observe for the pinch start, the pinch, and the pinch end events. So looking at this code, we realized that we could actually mock the event object, call each of those three methods, and pass in the relevant touches, and have a 100% code coverage of this feature class without having to involve any event simulation. So that was a lot shorter road to success than having to implement multi-finger pinch simulation, which would have been really, really hard. So let's now take a little bit of a look of how the Siesta UI looks. So as I mentioned, it's built on XJS, and I want to show you a small test I wrote that shows you how to target things on the screen. So I'm going to show you a bit of a code snippet here. I've created a little button factory class which just outputs EXTJS buttons into the DOM. So it renders it to the body. I add some text, and for each button, I want to assert that the button fires one click event through the course of this test execution. I also create a little window, and then all these buttons are being generated right here. So you can see I created with some different configs. I use an ID, a CLS, another ID, some value, icon CLS, and so on. And now to the nice part, I can actually target all these buttons individually using all these different options. So I can pass in a coordinate, I can pass in an ID of a button, a regular CSS selector, and now it gets interesting. This is a real EXTJS component instance, the BTN4. And here you see it's a native DOM element instance, an ext element instance. And here we see some strings. So with these double leading arrows, it's a component query. So using this component query, hopefully I'll be able to target this one. And here's another one which we have come up with, which is called composite query, which is a combination of a component query on the left and a CSS selector on the right, which gives you very expressive power to target things on the screen. So, and at the last point, we're doing a drag of the window and finally clicking the button inside the window. So let's take a look at what this test looks like when we run it. So you can see it's testing, clicking each of the buttons that we saw on the page. We can run it one more time, one by one. And it's now running in slow mode, which you typically wouldn't do, but for the sake of demonstration, it's a bit better to run it like this. And you can see that it's actually finding something interesting here. So it's passing all these 8 assertions that the buttons work. They fire a single click event, but it also finds some bug. It seems that we have a global variable leak inside of our code. And if we go back, and I'll increase the font a little bit like this. If you go back, you'll see there's a my global without the bar keyword. So let's try to fix that and go back, and we can run the test again. And this time, hopefully, we'll have a better result. Yeah, and now we have a full passing test suite. So this is a very simple test again, just to show you how you can locate things on the screen. So you can also make this even more advanced, and we use this Siesta tool to test our own components in our nightly builds. So for example, our scheduler for XJS has a quite complex plugin which allows you to edit events in the schedule. So a bit of a more advanced end-to-end test of this plugin looks something like this, where you can see we click on various places on the screen. We also do a bit of a drag drop to create a new event, and so on. So you can do a lot of these complex interactions. And as I mentioned, you can also launch this from within your IDE. So this is WebStorm. I can hit my favorite key command, and this is going to take, I don't know, a few seconds. And I have the result in my IDE. I don't even have to go out to Chrome. And you can see that I'm actually launching it against multiple versions of XJS, since we support 2 versions right now of XJS. So all from within my WebStorm IDE, which is very nice and time-saving. So having said that, I'm going to pass it back to you, Arthur.
So let's see. All right, thanks, Matt. I'll wait for the ball here. Okay, so as I mentioned earlier, there's a variety of resources that I'd like to share with all of you, and don't go rushing to write all of these URLs down. I'm going to put my slides up on Twitter, the Sencha forums, Facebook, and a variety of other channels. But first and foremost, here we go. First and foremost, I wanted to share with you links to the 2 articles that I have previously written for the Sencha blog. The first one was on how to automate your unit tests, which covers both the syntax and the logical unit tests. And then additionally, just a few weeks ago, published UI Testing a Sencha App. Both of these articles deal with the sample app you saw today. That sample app is available on GitHub at that link. And additionally, Siesta has the link there at the bottom. But there's a lot more information about unit testing in general. So we only had about 45 minutes today to cover some of the high-level things. And there's just tons and tons and tons to learn. So here are a variety of other resources that I would highly recommend for your reading and viewing pleasure. First is a book by Christian Johansson titled Test-Driven JavaScript Development. There's a great presentation by Rebecca Murphy called Writing Testable JavaScript. Her presentation is available both on YouTube for the video and speaker deck for the slides. Davis Frank has a good presentation on Jasmine, which is on the Sencha documentation. I think this comes from one of the previous SenchaCons that we had. Sencha's Arya Hidyat has a fantastic presentation on JavaScript code analysis with Esprima, which is available on YouTube. And finally, Reed Burke, who's on the YUI team, has a great presentation from a recent YUI conf called Write Code That Works. So if you're really dedicated to learning more about how to write unit tests in JavaScript, whether that be for your syntax, your unit tests, or your integration tests, please check out all of these resources. In closing, I wanted to offer a few pieces of advice. First is that when you set out to write unit tests for your project, you should really try to decide what those tests are going to accomplish in your project. So tests are a great tool for having great code quality, but having 100% code coverage should not be the goal. And I say that because just because your tests pass doesn't mean you have working code. There are plenty of bugs that will get into your code base and still have your tests pass. Writing tests will make you more aware of your code, and ultimately what I found about unit testing is that it helps you learn from your mistakes and it helps you to become a better developer. Your unit tests should complement an existing testing process, and by that I mean when you go through a release cycle for your application, nothing's going to replace users physically going through the app to make sure that it functions correctly. Unit tests won't solve that problem, but they will make that problem easier. It'll make that testing phase shorter, and it will make your application that much easier to maintain in the long run. So thank you very much for tuning into today's webinar. I'm assuming we have a lot of questions, so I'm going to pass the ball to Luke. You can tell me if there are questions that we can try to answer for the community.
Just leave the Q&A slide up there. You can keep the ball hurt. Okay. So I've got quite a few questions here, and there's more coming in. Okay. First up, what was the theme visible in the XJS slide and the trailing slide? People really liked it, and they wanted to know what it was.
To be perfectly honest, I don't know. I wasn't paying attention that closely to my intro slide, but I will try to find out, and maybe I can post that to Twitter or the forums or something.
Okay. Let's see. There's browser metrics that were used. I'm going to sit that. What linter do you use in your projects?
What linter do I use?
Yes.
So since I've started developing that lint roller tool, I find myself using those three linters that are supported in there, which are JSLint, JSHint, and Esprima. And while that's terribly redundant to use multiple linters, I find that each of those tools offers you different feedback, especially when you start playing with the variety of options that each tool allows you to use. So I personally like JSLint, but as I mentioned earlier, not everyone agrees with Douglas Crockford. So that's not a knock against him. It's not a knock against JSHint, because JSHint is fantastic. But I kind of like having feedback from multiple sources. But that's just me. And there are a variety of other tools out there that do this that are not currently supported in the lint roller tool.
Okay. Then this is for Matt. Can Siesta be internalized to work in a VPN environment?
Yeah, since it's fully run in a browser, as long as you configure your browser to work inside of your VPN environment, things should just work. So, for example, if you use Selenium, the web driver from Selenium, you might have to customize the copy launched by the Selenium runner to get that to work with your VPN. But yeah, this should work.
Okay. So a lot of questions here are about Siesta versus Jasmine. Is there any reasons to still use Jasmine for unit testing, or can you give a sort of a compare and contrast between the two?
Should I do it, or Art? Or?
Yes.
So, well, I'm obviously biased, but we internally, and by we I mean Brinton, we use only Siesta because Siesta also allows you to do plain simple unit tests, just to do logical comparisons. The upside of Jasmine, though, is I think people like it a lot because you get very, very readable tests. You can read it to a child almost. And that's a huge thing, because when you think about it, a big test suite is also something you have to consider being your product. So your test suite has to be maintained. If you just forget about your test suite, then after a few years or a few months, it might just get in the way, because nobody knows what the tests are doing anymore. So the readable aspects of the BDD in Jasmine is very nice, and we're actually adding a BDD layer to Siesta as well, because it's been frequently requested since we launched.
You know, if I can jump in for a second too,
yeah.
You know, to kind of add to that, the reason I chose to use both Jasmine and Siesta in the sample project was really to show a variety of tools. So there are, you know, probably 30 at least JavaScript logical unit test frameworks that are out there, Jasmine being one of the more popular ones. And certainly if you're going to try to do both logical unit tests and your functional or your user interface tests, then using Siesta to do both of those makes perfect sense. There's no reason why you would necessarily need to have both. It was, from my end at least, trying to show that there are multiple ways to solve the same problem, multiple tools that solve the same problem, and if you're going to do like an all-in-one solution, Siesta seems like it's perfectly fine for that.
Okay. So question probably for Matt. What version of Sencha Touch and Sencha XJS does Siesta support?
So it's a bit of an interesting question because as a JavaScript testing tool that Siesta is, it supports any type of JavaScript. And the interesting part, of course, is the adapters we have, because we have adapters for Sencha Touch and adapters for EXT. And right now, we test against EXT3 and EXT4, and it works very well. For Sencha Touch, I think we support Sencha Touch 2 and up.
Okay.
So yeah, but again, you can run any type of JavaScript in there. It just might not give you the full sugar and the abstraction levels that we get from the adapters.
Okay. Is unit testing available for XGWT? Actually, I'm going to leave that one. Is there a solution for testing an XJS MVC controller that would contain most of the interaction logic U code, but currently depends on a loaded application project? That might be a little bit more complex to run here. Is it possible to automate the unit tests for Siesta?
Yes, absolutely. So we have a bit of a freemium business model. So the free version comes without the automation adapters, and in the paid version you get the scripts required, which you can use for Phantom.js if you want to use that, or if you want to use Selenium, which is what we actually use to do multi-browser testing every night.
Okay. Is there a way to test Sencha Touch inside the UI WebView container or running the Sencha app as native?
So can you repeat?
Is there a way to test Sencha Touch inside the UI WebView container while running the Sencha app as native? That one might be for Art or you, I'm not sure.
So I can try to answer that. The solutions that I've seen so far, and there's probably lots of things out there that I'm not aware of, but I haven't seen anything that is currently a fantastic solution for that. I think you probably could hack to get Siesta in place inside of a web view and try to go down that road, but that's going to be a lot of work. There are some tools that I've seen that are currently in like an alpha state, and off the top of my head, I can't remember this one tool's specific name, but I know that these sorts of tools are being developed because there's another sort of side question to this, which is how do I automate testing across many devices, not just a single web view on iOS or a web view on Android or what have you. So there are tools that are coming down the pipeline, but in my travels, I have yet to see one that really solves that well. Maybe Matt has a different take on that.
Well, we've actually recently had a few questions regarding testing inside a UI web view, and we found one issue or two relating to that. But I think since it's just a web page under the hood, that it should be definitely compatible. But we're actually looking into that right now. We'll probably get to that next week.
Okay, cool. Any advice on integrating Siesta testing into an app that's been developed for more than 2 years?
Well, that's kind of, I don't know, it's an interesting question, and it's come up quite a bit because there are basically two ends you can start. Either you have not written your app yet and you're writing the tests as you go along, or you have written a huge app that now is maybe due to refactor, maybe upgrade from 3 to 4 or so on. So this is a very relevant question. You could definitely write these black box tests if you want to have some type of reassurance that the application as a whole works before you go down the big refactoring road. Or I would probably try to isolate one component at a time, one class at a time, cover it with tests before you actually start refactoring everything, so that you can actually refactor something that has test coverage. That gives, at least gives me a lot more confidence when I do it.
Okay. Well, I think we're kind of running out of time here. A last question here. Does Sencha offer consulting services for guidance on writing more complete unit test suites for more complex Sencha Touch applications? I'm going to give that one to Art.
So the answer to that is yes. Our professional services team would more than likely be able to handle a scenario like that. We do a variety of consulting type work. So if you want to know more about that specifically, certainly contact Sencha either through the website or reach out to me directly, and I'll put you in touch with the manager of the professional services team.
Okay. Well, and thank you for both of you for presenting today, and we will be posting the recording shortly up to Vimeo. And I know there's a lot more questions in the chat window here if you guys want to take a look through after and you know, start some threads up on the forums. That would be the best way to get a lot of these answered. So I know Matt and Art will take a quick look there too. So thank you everybody again, and we have another webinar coming up in the end of February. I'm not quite ready to announce the theme, but do keep 10 a.m. on February 21st be open, because it's going to be a really, really interesting webinar I have coming up for you. So thanks again to Art and Matt. I'm Lee Kilpatrick signing off, and happy testing out there.
Thank you, everybody.
All right. Bye-bye.